Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akil bin Muhammad Zaidi. My matrix number B1123100085. Everyone, today I am going to present our title project, Smart Environmental and Monitoring and Gas Leakage Alert System, which we developed for the BELR2373 embedded system subject. First of all, the rapid development of embedded system today allows us to create smart monitoring solutions that improve safety and efficiency. Our system combines microcontrollers and sensors, also communications modules to continuously monitor temperature, humidity, and hazardous gases such as LPG and methane. Furthermore, what makes this system important is its ability to detect dangers early and automatically trigger alerts using visual signals, sound alarms, or wireless notifications. This early warning can help prevent accidents, reduce property damage, and most importantly, save lives. The system operates in real time, offering high reliability while using minimal power. For example, making it practical event for continuous use. The last is this solution ideal for homes, factories, and laboratories or other confined spaces where gas leaks could pose serious risks. Last but not least, it is designed to be scalable and cost-effective, making it suitable for small or large-scale safety applications. In short, this system provides peace of mind, ensuring that hazardous conditions are detected and addressed before they become disasters. That's all for me. Based on introduction, thank you.
Hi, my name is Muhammad Izzat Ikmal bin Ahmad Ruhidin. My number is B11231097. Alright, today in this video, I will explain how the Smart Environmental Monitoring and Gas Leakage Alert System works, step by step. First, the heart of our system is the Arduino Uno, which serves as the main controller. Then, it continues to monitor 3 key environmental parameters: temperature, humidity, and gas concentration. We use the HT11 sensor to measure both temperature and humidity, while the MQ2 sensor is responsible for detecting the presence of gas. Then, based on the reading, the system automatically triggers the necessary outputs such as LED indicator, a buzzer, a cooling fan, and real-time updates on the LCD display. The system operates in a continuous real-time, meaning it constantly reads data and responds immediately to any change in the environment. Lastly, it's designed to run autonomously with minimal power usage, making it suitable for continuous operation in various settings. Okay, now we go to the process step by step. First, we have startup process. When the system is powered on, it begins by initializing all components, including the LCD screen, the gas sensor, and the temperature and humidity sensor. It also displays a welcome message on the LCD to confirm that everything is working properly. Then, for gas detection, the MQ2 gas sensor constantly reads the gas concentration in the air. The readings are mapped to a value from 0 to 255. Based on this value, the system determines whether the gas level is safe, at the warning level, or dangerous. Depending on the condition, the appropriate LED lights up and the buzzer is triggered only if the danger level is reached. Okay, next, for temperature-based fan control. At the same time, the system checks the temperature using the DHT11 sensor. If the temperature is between 30 and 50 degrees Celsius, the system turns on a cooling fan. The fan speed is adjusted using PWM control. If the temperature is outside this range, the fan stays off to save power. Lastly, for display and reset, all data, including temperature, humidity, and gas level, is shown in real time on the LCD screen. If there is an emergency or false alarm, the user can press a reset button. This will turn off the buzzer, LEDs, and fan, and the system will restart its monitoring process. So overall, the system runs in continuous loop, always checking the environment and reacting automatically to keep the area safe.
Hello, hi. I'm Sudendran Analaki Tilagan. My matric number is B1124100161. So today I'm gonna present about my point about the flow chart. So let's begin to the explanation. So the flow chart here, which I have shared, represents a gas detection and alert system using sensors and output devices. So below, as I showed in the picture, there's a step by step. So I will explain it by accordingly. So the first, start with the system begins operations. So second one will be initialization. Initialization, the microcontroller initializes all necessary components such as LCD display, gas sensors, which is MQ-2, then the temperature and humidity sensor, and for the last part is input and output pin. Next, we'll move on to the sensor reading. The system reads gas concentration using MQ-2 sensor. The next will be temperature and humidity from the DHT1111 sensor. Sorry. The next will be about display data. The measured values and the temperature, gas concentration are displayed on the LCD. So next will be decision making, gas level analysis. The system checks if the gas level is on green means it's safe, yellow means kind of warning, and red will be dangerous. Okay, the next will be 6 output actions based on the gas levels. So as I said before, green is for safe. So we turn on the green LED, then turn off buzzer, and the buzzer will turn off, and the relay also will be turned off. If yellow, warning means the LED will be turned on and the buzzer will turn off, but the relay will be turned on. If red, as I said, for dangerous, it will that LED will be turned on. The buzzer also will turn on. At the same time, the relay also will be turned on. So to reset the thing, after a red alert, the system waits for a manual reset button to press. So we should press the reset button. So once the button is pressed, the buzzer, relay, and the LED all are resetted and will back to the initial state. So overall, for last, the system finishes the current loop and may restart, or depending on the design actually. So this system is typically used in an environment where gas leaks are risk, such as kitchens, factories, or labs, and it's designed to alert users and possibly take automatic action to prevent hazards. Alright, thank you. Next, we move on to the next slide, which is about the circuit or the stimulation circuit I've constructed. So I'll give explanation regarding it. So this circuit is as I told before, this is a gas leakage detection and monitoring system. Circuit built using an Arduino Uno, an MQ-2 gas sensor, and DHT11 temperature and humidity sensor, and LCD display. And last will be alerting components like LED, buzzer, and relay. Here's a detailed construction and working explanation I will explain to you. So the circuit is constructed with main components, as I told you before: Arduino Uno, MQ-2 gas sensor, and DHT11 sensor, LCD display, buzzer and relay, and reset button, and NPN transistor, and variable resistor, and BAT1 power source. So I will explain to you step by step. So the first step will be initialization or power on. So it's a simple power on. So Arduino initializers all connected peripherals such as LCD, the sensors, whatever sensors like what I told you, like MHDT11, MQ-2, then MHDT11 and IO pins. So will be connected respectively. Then LCD gets ready to display the sensor readings. That's the first part. Second, the sensor data reading. So MQ-2 sensor output analog voltage based on the gas concentration. Then another DHT11 sensor sends temperature and humidity digitally via data pin. So next LCD1 display. So LCD will show the temperature reading, humidity reading, and the gas level in the percentage. And next, the gas level decision logic. So Arduino compares the gas sensors output with the preset thresholds. So green LED light turn on, gas level is safe, as I explained in the previous slide. So if yellow LED is turned on, it's considered as a warning. It's a warning. Gas is present but within a warning range. So if red LED and plus there is a buzzer sound or relay is turned on, the gas is at dangerous level. So next will be alert mechanism. If a danger level, as I told you before, the red color light blinks, buzzer sounds will continuously. Then the relay activates. So to start the exhaust fan, and the red LED will glow. So once all complete, last we'll go for manual reset. So which red alert is activated, the system waits for reset button to be pressed. So once the reset button is pressed, all outputs, buzzer, relay, LEDs are reset, and monitoring resumes from the beginning. So it's like reset back and we're back to the initial position. Okay, so I'll be talking about the wiring part. So MQ-2 analog output connected to AO on Arduino, and DHT11 sensor data pin is connected to digital pin 2, and LCD connected in 4-bit mode. It's considered as from pin 7 to 12. Then buzzer connected via NPN transistor and controlled by pin 5, and LEDs controlled by pin 6, which is red, and 7 for yellow, and 8 for green, and relay controlled via pin 4. And for the last, the main part is one of the main things is like reset button to a digital input, which is typically pin 3 with a pull down resistor. So Last, I would like to conclude my overall circuit which is constructed. This circuit is designed for real-time gas leakage monitoring, so commonly used in homes, labs and industries. So it provides a multi-level safety indication, like as I told you before, the three lights, green, yellow, red, along with automated and manual response option and reload activation and reset. So thank you.
Hello, Assalamualaikum. My name is Muhammad Alif Aiman bin Anwar, and my number matric is B1123710073. Today, our group will be present about our assignment, which is Smart Environmental Monitoring and Gas Leakage Alert System. For task program, this is the coding that we are used to make this assignment and to make this software run success. And the explanation about this project is the Smart Environmental Monitoring and Gas Leakage Alert System begins by initializing all necessary components, including the LCD display, MQ2 gas sensor, DHT11 temperature and humidity sensor, and input-output pins. Once initialized, the system continuously reads gas concentration level from the MQ2 sensor and temperature and humidity data from the DHT11 sensor. This data is then displayed on the LCD screen in real time. Based on the gas readings, the system determines the safety status. If the level is safe, it activates the green LED with all alert off. If moderate, it turns on yellow LED and activates the fan through the relay, but keeps the buzzer off. And if dangerous, it triggers the red LED, buzzer and fan to alert to the user of critical situation. The system then waits for the user to press a reset button, which deactivates all outputs, which is buzzer, relay and LED, and restart the monitoring cycle to ensure continuous safety. As you can see here on this slide, this is the condition of no gas and the LED green on. So as you can see here, the LED green is on, the motor off, and the buzzer is off. For the second condition is gas detect, and the LED yellow and the LED yellow is on. And therefore, third condition is gas danger, LED red on. For this condition, the red LED is on, the motor is on, and the buzzer is on. On the LCD screen, it will say, stay alert, gas danger.
Hi, my name is Muhammad Jihad Saifullah bin Sharmisa. My matric number is B112320056. So this is a last slide for my group. So my group title project is the Smart Environment Monitoring, Gas Leakage and Alert System is successful achieve its objective of providing a real time to detection the first successful to detect the hazardous gas in a real time, provided clear alert using LED, red, yellow and blue, buzzer, fan and LCD display, ensure safety to the autonomous and responsive operation. So for the system, we have a low cost, scalable and reliable solution suitable for home, labs and factory and confined area. Module Arduino based on design for easy customization. So we use Proteus and coding Arduino. For future, we can add a wireless alert using a Wi-Fi or GSM modules, or data logging for environment analysis, AI or machine learning for productive gas leakage for detection. For Arduino, the system cost-effective solution is easily to application, scala form reduction and industry setting. It's a multitask model alert system and proactive response mechanism make particular and valuable for preventing accident in confined space where gas escalation and overheating pose sharing a risk. So that's all for conclusion. Thank you for watching.